All right, let's go over problem number 1 from your in-class assignment. We have the function g of x, which is a piecewise function defined in two parts. It's x cubed minus 1 if x is less than or equal to 1, or the square root of x plus 3 when x is greater than 1. So we have two different functions. We have a cubic function, okay, which looks like that kind of squashed S shape, and we have a radical function, which looks kind of like that funky check. It's almost like the radical itself almost looks like what the graph will look like. All right, so I'm going to do this in two colors to represent the two pieces. First, I'm going to do x minus, or when x is less than or equal to 1 in red, and then when x is greater than 1, I'll do that in blue. So I'm going to go ahead and make a nice little t-chart here, okay? And I'm going to figure out that my fence is where my inequalities are. Well, my inequalities separate the function at 1, okay? So on my graph, I'm going to go ahead and put a little horizontal dashed line at 1 because I know I'm going to have the red function on one side of it and the blue function on the other side of it. I can also put that on my t-chart, okay, where that's going to be 1 and 1. All right, so let's go through and evaluate functions where the value of the input is less than or equal to 1. So I've got 1 already. Well, what's less than 1? Well, 0, -1 are easy enough ones to go through and do, okay? And they're all less than or equal to 1. So let's evaluate the function at these 3 points for the red function. So if I plug in -1, I have -1 cubed minus 1. Well, -1 cubed is -1 minus 1 is -2. If I plug in 0, I have 0 cubed minus 1. Well, 0 cubed is 0, minus 1 is minus 1. If I plug in 1, I have 1 cubed. 1 cubed is 1, minus 1 is 0. So those are 3 points that I can go through and plot. So I can plot -1, -2. I can also plot 0, -1, and then because it's x is less than or equal to 1, I can include this point and do 1, 0. Okay. Now, right now, that looks kind of like it's going to make a straight line, but I know that this is a cubic function. Okay. So maybe I need to find one more point. Maybe I'll go through and plug in a -2. If I plug in a -2, well, -2 cubed is -8. -8 minus 1 is -9. So I can go to -2 and -9 way down here. It's not even really on the grid anymore, okay? But I can put a point down there, and that'll help me remember that this is a cubic function, so it's going to kind of look like that sort of squashy guy, okay? Like a squiggle, like kind of a squished S like those cube roots did, okay? Only this one's going vertically. So that is the first piece of our graph. The second piece is going to come from where x is greater than 1. Well, I want to be smart about this because I'm doing square roots, okay? So I want to try and pick smart numbers. If I plug in the number 1, that's going to be the square root of 1 plus 3. Well, that's the square root of 4, and the square root of 4 is 2. So lucky me, that was a smart number to pick. However, I need to remember to put an asterisk there because it's really where x is greater than 1. So this ordered pair is not included, but I can go ahead and use an open circle to graph it. Okay. The next point I want to pick, well, can I pick 2? Sure, but then I'd have to take the square root of 5. Can I pick 3? Well, sure, but then I'd have to take the square root of 6. So maybe I want to skip all the way to, I don't know, let's say 6. Okay. Why would I skip to 6? Well, because 6 plus 3 is 9. What's the square root of 9? 3. So it's a nice, pretty number. So I can go 1, 2, 3, 4, 5, 6, up 1, 2, 3. I've got another point right there. Now, could I have gone through and plugged in a number, say like, 3, and gotten the square root of 3 plus 3, and that would be whatever the square root of 6 is written as a decimal? Sure, you could do that. It might even make it easier for you to go through and graph it. I normally try to go through and pick the nice pretty numbers, but if you need to, you can just grab a calculator and go do all of that fun stuff. So just for grins and giggles, let's say that you did go through and try and find the square root of, what is it, 6? So yeah, what's the square root of 6? 2.449, so call it, 2.4-ish. Okay, so could you go, oh, I'm gonna go pick 3 and like 1, 2.4. Yeah, you could do that. Okay, but it essentially is going to go through and look kind of like this guy, all right? Because that's really what those radicals look like, right? They've got kind of that swooshy shape to them. So you've got yourself your piecewise function. You've got the left piece, which was this cubic. You've got the right piece, which was this kind of square root function. And you've got both pieces done. All right. Now, in terms of finding any points of discontinuity, well, what do we have there? We got ourselves a jump. So is it continuous? No. Where does it have its point of discontinuity? So point of discontinuity would be where x equals 1.